Okay, guys, this is the part 2 or the part B of the video. Um, so let's continue with from where we stopped um, in the previous video. So we are trying to insert the values into the entry box. So remember to put this double colon here, and then you could use dots. For example, if you want to put your values in four decimal places, so you could use 4F, and then this does the job for you. So let's quickly let's insert this command there and see what happens. Let's insert this command in just in the command button, so and see what happens there. So this is the calculate command button. So let's go command equal to calculate command. Great. So just to confirm here, so let's run this and see what happens. Okay, I think we've made a mistake um with our with our code. Okay, I think syntax error. So let's go back there and fix it. While teaching, you are trying to put up a lot of things, so somehow this is supposed to be, yeah. So let's try this again. Great. So let's do this. Okay, we've not put in values. Let's say we put in 5,000 here, we put in 500 here, we put in 0 points. These are just typical values, 0.7, and then we have 0.5, 0.7. Let's leave that 0.7. Calculate. Oh, we've got an error here that said could not convert string to float. Okay. Let's so what happens is this for our combo box, we mistakenly did not we forgot this. We could not convert a Vasquez for example, to float. So what will happen, because we are not using it, I'm going to pull it off here, but basically where I needed us to use it was to use it in an if statement. If possible, I'm going to just show you an example, but I don't know how possible that is with a lots of things I have to cover in just 1 hour left. So let's hope it's possible. So let's run this again. Great. So we have 5,000 here. We have um, uh, 500 here, for example. We have 0.8 here. We have 0.7 here, or 6.5, and then we have, let's be using these values as standard values, 0.75. So we've got another error. They could not convert this to string to float. Oh, I think I made a mistake in the M3. I've used 0. Okay, great. So let's do this. Another error. Let's fix them one after the other, right? Yeah, so this is not defined. Okay, sorry, I forgot to do this. We have imported this, so PVT backend. I think I made a mistake. This is what we were importing. So we made a mistake in this module. So here you go, guys. Great. So let's do this again. So we have 5,000, and then we have 500. We have 0.85, 0.65, and 0.75. Okay, another error PVT backend not defined. Okay, what have we done this time around? Oh shit, this is what I made mistake. Was it PVT back or PVT backend? Oh, why do I keep making this mistake? For God's sake! But it's good for you guys anyway. You are learning. You are learning. For example, I'll show you this. When you see a name not defined, it's obvious and it's very clear that you've probably made a spelling mistake. Okay, great. So let's go in and try this one more time. Great. So let's try this. Let's hope we didn't make any other mistake again. But even if we did, no big issues. You should be ready to resolve a problem, solve problems, and resolve the issues. Okay, so gas gravity 0.65, and then Z factor 0.75. Okay, let's hope. Fine, great. So you could see our gas oil ratio here. So if we do same for exactly same for these ones, I think we are going to do great. So now also notice it's actually okay. I think I've closed that already, right? Okay, but you will notice it was 4 decimal places. I don't want to run it again, but let's just quickly go on. Let's quickly put in insert other parameters. Now I'm gonna do this again, but I want to show you guys something before I go on. So let's run this again. Now let's put in these values again, 5,000, and then we have 500, and then we have we have 0.86, 0.85 rather. We have 0.65, and then we have 0. Well, this Z factor also 7.5. Okay, so now you see 4 decimal places. Yeah, so this is 4 decimal places. Now I'm going to show you something. If eventually I change this to 600 and I do the same calculation, you'll notice that this appears here while this is still here. So we have to do something about that so that this clears the former values here for a new one to come in, and that is easy. So see what we see how we can what we can do about it. We could use the if5. You could use the method, the delete method. Yeah, so we use 0 and we use end. So what this simply means is from index 0, the start to the end, wipe out everything, delete everything. So with that, we won't have issues like this anymore. So we have to close this and rerun it. Okay, so let's have 5,000 here, and then we have 500 here, and then we have 0.75, 0.85 rather, and then here we have 0.65, and then here we have 0.75. So if I calculate this, I get this, and then if I, for example, I change this to 600, so you see it's good, it's cleared out the other one. So that's basically the purpose of that delete function there, that delete method there. So let's do exactly same for other ones, but I'm not going to waste time doing that. It's just to repeat the codes. I'm going to just copy directly from here already written out. So okay, so let's just get it from here. Okay, so I'm in 2 decimal places, but does it matter? Okay, it does. In yours it probably does for you. So yeah, so with this we can be sure we are set for every calculation. So I want this to be 4, or do we leave it 2? Let's leave it 2, or 2. Okay, so with this we are doing great. So let's get this. So with this 5,500, 0.85 and 0.7565 and 0.75. So these are typical values for those parameters. So you see all these are calculated. Now, okay, gas formation volume factor is usually in the range of 10 raised to power minus 3 and above. So we have to make it 4 decimal place. In fact, I prefer we make every one of them 4 decimal place, or you could do yours like that. So yeah, so this is for each of the entry in delete and insert, delete and insert, delete and insert. So for each of those, so basically that is it. So I think with this we are done with the command function, and we need to go to the next function, which is actually the run sim. So here it does, and then have I closed it? Okay, let me open. Okay, we could use this as so. Run sim does nothing yet because we've not given it the command. Close does something, we've given it the command. This does something, we've given it the command. So it's just this run sim that doesn't do anything. So if, for example, our reservoir pressure is 3.5, okay, when we calculate, you see the adjustment. So this run sim doesn't do anything. So let's quickly work on that and let's see what to do about that. So let's give it a command just like other ones. Command, and then we give it a run sim command. Let's call it a run sim command. So we'll use this to create a function. Now the function basically, understand, it basically does the same thing with this one, only that it's actually iterates over it. So look at what we can do. So first let's define the function out of this indentation. It's no longer in that function. So let's put that, Control Z, run sim command. So yeah. So first of all, we are going to we want to do, understand, want to do something that iterates through the values given at certain step size or with certain step size. So if, for example, you are given 3.5 here, it could iterate taking values of 100 from 3.5, 3.4, 3.3, 3.2, 3,100, 3,000, and then using it to check this, using all these other ones will not be changing. Yeah, so just this pressure, and then using it for in the formulas for all these calculations, and then getting all those values and putting them in here. That's basically what happens. So it's almost the same thing, except that we'll be using a for loop. We're going to be using a for loop for iterating. So let me show you how this thing works. I'm going to go to another cell to show you how it works. So this is the for loop, how it works. So if, for example, I have x equal to a list, for example, like 1, 2, 3, 4. So this is how it works. I could say for I in x. For I in x, I've not put my this. Okay, this is how this is the syntax of the for loop for ix. Now I forget about what I is just the ith value. It could be anything, or you could use any value or any variable other than y. Anything you put in there doesn't matter so much. But you're going to be using it later when you need it. So let's put in something. Let's put in something in there. So if this thing simply means for each of the values in this x, for each of the values in x, perform this operation. So one after the other, it goes one after the other till it gets to the end of the list. So for I in x, let's say, for example, add +1 to I. So what this simply means is that I should be equal to I but +1, or let me say plus, no, let me not use times, plus, let's use times 2. Yeah, so this is what happens. It's going to take 1 multiplied by 2, take 2 multiplied by 2, take 3 multiplied by 3, one after the other, and then by the end of the day, it will print this whole thing out. Print I. So that is how the loop will run. So Okay, sure. So here we go. So this is how the for loop work. So it takes this and then takes each multiplied by 2, this multiplied by 2, this multiplied by 2, and this multiplied by 2. So that is how the for loop works. So we need a sequence for the for loop to work. So this is a sequence. Sequence is a list. A list is a sequence. A tuple is a sequence. A dictionary is a sequence. So there are a lot of a number of sequences in Python. Let's quickly see how we could use this. So why do we need a for loop? So okay, before that, you will still need to know how the concept range operates. So there's a function called range. Yeah, so it's another it's something used to create a sequence. So it generally has three arguments you have to pass. So the first argument, whatever you are putting as the first argument, is expected to be the first value that will be in that list. For example, I want to count from 1 to 100, so I want to iterate from 1 to 100, and then in steps of 10, this is the highest, this is the lowest, and this is the steps. So what it's going to do now is going to go step by step. Okay, let me print this separately first. Okay, it's not going to print unless I convert it to a list. So so it's going to okay, it's still good. I show you how this works, the range works. Yes. So if I say X, it's still gonna print X, I guess. Okay, so if I say okay, so this is basically just the range. So if I run this, you see what happens now. It goes okay. What will happen? Let's just say print I. So see what happens. It goes from 1. I could start from 0 if I wish. It goes from 1 and then 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that is how it steps. So that is how it works. Now it's in steps. This last argument is expected to be the step size. And then you could go backward using minus in the step size and then putting the highest here. That is where you want it to start from. It always starts from this one here. So when you do this, 190 goes downwards. So what we want to do, we want to step from the highest, the pressure up given to us, and then want to step downward. And as we are stepping downward, we are using each of those pressures to make our calculations. So the whole thing is pressure dependent, right? So that is why we are going to use the for loop. So P, we're going to use the pressure. It's only the pressure we are changing. So for P in, okay, sorry, in, now remember the P will be the value supplied. Okay, what will happen? I have to get this up again so that I could use it for demonstration. So what I will just do here, 1, 2, 3. Okay, we'll just delete it anyway. I'll just copy it. Okay. Okay, so let's run this first. Oh, I've already. Okay. Where did I put that? Where are the buttons? Okay. Okay. So let's run this. I want to see the app first. Show you something. Okay. Okay, great. So see what happens here. So the pressure, what happens is that it takes this pressure. Okay, sorry about that. It takes this pressure and then it steps through it, like I explained earlier. and then it gives you values here, values here. Now see what I'm going to show you now. See what I'm going to show you now. What is happening? Commands. Okay, let's quickly delete this. Great. So we are good to go. So let me show you something. Okay, so the pressure actually takes in this value. So this is our E1, remember. So it takes in whatever value is here for, and then it wants to actually iterate through it. So that is why we use in this function, we use P here to be E1. So E1 dot get. So it takes this value. Yes. So in this particular command, the pressure assumes this value P given to it in the table, in the from the entry field. But here, it also does the same thing, only that it gets several values for P instead of a single value. So it gets values in steps of okay, we're going to use the range now. It gets values in this range. So let's convert whatever value we have to float. Sorry, no, not that. Range float. Okay, so see what it does here. As it gets whatever value supplied as the first value. So we are doing this range, right? So we are doing this is the first value, and then want to go negative. So we want to do it this way, 100 0. So we're going to put the lowest value we want to see in our table here. Want to see in our table here. So yeah. So let's say we want to see 100 as the lowest, and then we want to step through 100, step by 100. So this is going to be different sets of values for P. And then what we expect is that P, it does all this. Since P is different, since P now has this value, anything that is dependent on P should now take in those values to make calculation. So every other thing is going to be the same, but with this for loop, there's going to be a set of value of P, and then there are going to be a set of values of those which also depend on P, those parameters which also depend on P. So let's quickly see that. Sorry, I forgot my column. So that is why we are putting all this under P. Oh my God, what is happening? They're not responding. Okay. I hope we are set to go. Great. So what happens is that all these other values, although these ones don't depend on P, but there's not going to be any problem anyway. But these ones, every other one that has P, either directly or indirectly, is going to have several values as P has several values. So all that depend on pressure, we get several values as you change the pressure. So the next thing is actually to after doing this, to insert it. But one thing we want to do, this doesn't need to be in the for loop, is to use our our delete function to always clear our table whenever we run this thing afresh. So we use our delete function, 0 and end as the arguments we are passing. So that is what we did there. So with this for loop, for p in this, all these calculations will be done, and then the next thing we have to do now is to insert a table into to insert those into the table. So next thing we want to do is to actually insert them. So we'll use the insert function again, table1 dot insert. After all these calculations have taken place, we have to use table1 dot insert. So now just exactly the same way we did it, but let's there will be slight changes. Remember, this will be within quotation marks. Okay, great. So we need to put we are expecting a number of parameters. We're expecting 6 parameters, so we need to put in 6 placeholders. So but we have what we call tabs. We need tabs T. This will give spaces. I'll show you what this will do for you. So this, and then we have this again. Yeah. So yeah. So okay. So let's quickly do this. Dots. Now I'm going to show you something. Look at this. The space is limited, so we want to control the amount of character spaces each of these occupies, so that one doesn't bump into another. Of course, we want to use decimal place, but we need to give those ones that are not up to. There might be some that might not be up to that number of decimal places, and it will, of course, it will be filled with 0. But we still need to define a specific number of character spaces that can be occupied by each, since it's a table that is without border lines and all that, or grid lines. So and how we could do that is by using the using this. For example, you want 6.4f. Now what this simply means is there's going to be 6 spaces, and then this 0.4, we used 0.4 the other time, but I did not include this. Now this 0.4 simply means that there are going to be 4 decimal places. So we could repeat this for the rest. But there's something I want to show you we did here. That's a serial number. Serial number is mostly integer. So we could, okay, but first let's multiply this into 6 places. Okay, this whole thing into 6 places. So let's quickly do this. So we have 1, 2, 3, 4, 5. Okay, so we are good. Yeah. So let's put 1 for our serial number. It's basically the same thing, but for integers we use D instead of F. So let's use this dot 3D, right? Sorry, colon. That should be colon, not dot. So this is basically what we use for integers. So with this, let's count 1, 2, 3, 4, 5, 6. Oh, we still have one more to go, and it ought to be under this. So with this, at this point, we could actually break here with n, right? It's breaking with n that will actually make the next line, make the next loop line of this thing to stop and go to the next line, make this to stop at this point and then go to the next line, and then like that, because the for loop continues. Each time it prints this, print the next, print the next, print the next, and so that is basically how it works. So we're almost done. Remember, we are not done. So we need this dot format we used here. We use dot format here. Okay, so to put each of these, let's quickly put. We're going to be putting all of them in one, of course. So let's bring in all the parameters we are actually using. So the first one we are using is integer, is a serial number, and it's an integer. We'll use this. Okay. So I'm going to use P. I'm going to use that's pressure, right? So after pressure, the next is ROS, right? ROX. After that, we have the B naught, the formation volume factor. After that, we have the BG, the gas formation volume factor. And then we have the U, UG. Okay. So basically, this is what we have. So this should be ready. Let's check if our brackets is complete. Something tells me my parenthesis is not. So we have this and we have this. Okay, I think we are good to go. Okay, I think it's not complete. We have this here. Good. So except that we have not we've not actually done this. There's something we ought to do for the serial number, and we could do that so easily. So tired. Okay, so we could do that so easily. Serial number equals to 1. Equals to 1. And then we come here. We use SN here. Plus equal to 1. I think we are good to go now. We just have to move on. Okay. Okay. So this will make the serial number to be increased automatically by 1 each time. So it starts from 1, and then each time plus or equal to 1. So that is basically. Oh, sorry. What did I do here? Okay. So and we are using XN here, right? Sorry, it's not allowed. Okay. So I think we are almost good to go. So what will be left? I could break this with enter, but I will not use any other thing. It's not going to change anything. So let's just leave it. So that is basically what we have done. So let's run this to see where we are still missing it, probably. Great. So let's test our table. Oh, are we yet to? I think we are yet to tie up our function with this, because we did this last time. Okay, great. So if I use 5,000 and here I use 600 and here I use 850 and sorry 0.585 and then 0.765 rather, and then 0.75. Okay, so calculate gives this to us. Okay. So let's quickly look at our error before we proceed. It says in delete. Oh. Okay, let's go straight to that place. We have an error there. So okay, if we use 1 here, I'm thinking that might just work fine. So let's see this again. Yeah, once. Okay. Okay. So let's run this quickly. Okay. All right. Bad index 0. So that was our error. The table does not take in 0 as an index. Okay. So let's quickly deal with this. Great. So let's go there. 600 and then 0, 0.5, 0.7, and here we have 0.65. Okay, let's just quickly work on our error. Float object cannot be an integer. Okay, so we have to change that float to integer in that range. So the range function was expecting an integer, and I have mistakenly put a float value there. Okay, so let's quickly do that. So what it will actually do, it ensures that this is rounded to the nearest integer, because the range function is expecting as the first argument an integer. So it converts this to the nearest integer. So that's one importance of the integer function. So let's quickly run this and see what happens. I have to close this from our previous one. Let the fresh one come up. So if there's any other error, don't worry, don't be scared. We're gonna quickly, probably did not check very well why we are, we are in this class. So we have this. So great. So we still have index 7 out of range for positional argument tuple. So replacement index 7. Let's quickly look at that. I think we made a mistake there. Okay, so we probably have over specified this. Let's confirm that we have 1, 2, 3, 1, 2, 3. Okay, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So here we have 1, 2, 3, 4, 5, 6, 7, 8. Oh, we have over specified it. I just knew it. Okay. So let's go. Anytime you have an error, endeavor try to read the error message and see what's wrong. Gives you an idea of what's wrong. Then you correct it immediately. Still, we are still having errors there. Why scanning string literal? So I think I left an argument here in this insert function. I omitted an argument. So let's quickly confirm that so that there will be no other error in this. Confirm there's no other error. Where did I? Oh, I didn't close this, right? Oh my God, that's just it. That's why it said string literal. So it's all right. So let's go on. If I didn't, okay, this wasn't the problem anyway, it was the string. So let's quickly go on with this. Okay, hope we'll see the next error. And let's quickly see where we have probably left out trying to explain things. It's okay. Great. So this is what we have, but we are having a little problem here. Okay, so you could see something is wrong, particularly on the first row. It seems there's a little scatter here. A lot of things are not in place here. We have 1 here, we have 2 somewhere here, and then we have 3. And then a lot of things are not in place right now. So what we could do, the cost is actually the size of the character spaces. So we could actually decrease this or increase the size of the table. So let's try decreasing this 4 and maybe 3. for has to be lower than the other one. 4 and 3 because of the decimal point 4 and 3. Okay, this 4 and this is 3, and this is 4 and this is 3. Great. So let's quickly run this and see what happens. Okay. And yeah, so that's just it. Okay. 0.85, 0.65. Great. Okay, we still have similar problem and even worse. Okay, but this is working fine. We are going to do that now. Just don't worry, just stay put. We are working on, we are on that now. So let's quickly pull this off and go back to our code. The arrangement of our table. Okay, so let's quickly do some minor changes around here. Okay, so we have this. Okay, then we have this. Okay, we have something with BG, that's the gas formation volume factor. It has to actually be a little bit more than 2 decimal places. So I think we should look at it. That should be the third one from here. So let's make it 5. We are just going to increase the size of our table. I think that's basically the problem. So, but let's go with this first. Well, it's still going to be that way, but we'll just come here and increase the size of our table. Okay, so increase the size of our table. Okay, 0.85, and the gas gravity 0.65, and 0.75. Okay. Oh, even seems worse. Okay, what exactly is the problem? Okay, I think I need to use the horizontal scroll bar. So okay, that will be taking another time. I need it. Okay, let's quickly do this. Put enter here. I think this should be fine. Let's see this. Okay. Invalid syntax. Okay, I see something. But that couldn't be a problem. It's just my Russian. Okay. So if we have 5,000, we have 500 here. We have 0.85. We have 0.65. Here we have 0.75. Just make sure it enter. Oh, beautiful. So we are good to go. Except that this is not aligned very well. Now all you just have to do is using spacebar and all that, just make all these spaces. Oh, fine. I'm not gonna do that again because I need I need one more. I need the closest time possible. I need to finish up this. I think what is left is the matplotlib. I need to gain the smallest time possible. So what is left is the matplotlib. So let's quickly import matplotlib functions. Okay, we are done with that. So it actually calculates that. So let's quickly go to the matplotlib function. Let's import it. So there are several things you need to import here. Import matplotlib. Okay, sorry. Let's put them among. Let's just arrange all these imports in one block. Shift all these other ones down. So we have import matplotlib Then more than that, from matplotlib import plt. Okay, let's do it this way. Matplotlib.pyplot pyplot import plt. So with this, we are good to go. The next thing we want to do now is to now I could stop here and just quickly put the plot, the code, the matplotlib codes. But one thing you have to know, I saw some of you guys doing it. Let me just help you with that so that you will know how to embed your matplotlib in a new Tkinter window instead of just like just trying to just plots, and then when you plot, it's plots just in the note in the Jupyter notebook here. So let me just show you how this thing works. So if we have two values, how the matplotlib work. Before I forgot, if you do not have matplotlib installed, all you just need to do is to right click install matplotlib over here, and it will install. And then when you run it to install, so I've already installed mine. So good. So if I have X to be this range, I'm going to leave that range. So and then I have Y to be maybe a list. Okay, no, let me still make it something that looks like this. Okay, a list of maybe 10. 10, okay, 5, 15. I'm going to be doing about 10 of this. 15, 20, 25, 30, 35, 40, 45. So I think that is enough. Oh no, it's not up to 10 yet. 15, 55. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3. So if I want to plot this PLT, oh, I need to close this first. Oh, I've done something wrong. Oh, I wanted to skip. I'm so much. Don't mind me. I actually wanted to. I was rushing over the whole thing. So this is plt.plot, and I think we may need to put plt.grid as well. So okay, we could put this above here. Okay, and then we need to also show the plot. Anytime you plot, you always have to show it. So much in haste. So what am I missing? Okay, I think I'm getting exhausted. It's all right. I think okay, it says name PLT is not defined. I probably have not imported this. Oh, I see. So bad. It's not supposed to be from matplotlib. I'm supposed to import this as PLT. Okay, great. So this should work now, and this should work. Okay, this we are working. Okay, but first we need this to go out of the way. Great. So this is how matplotlib works. Already we have seen that in the tutorials. So let's quickly, but we don't want it to be plotted here, right? We want it to be plotted on the Tkinter window. So there is something we need to import, and let me quickly do that. So, and that is the matplotlib backends and aggregating it to Tkinter. So from matplotlib.backends.backend Tkinter aggregation or whatever, I just see it like that is how I see it. Import figure canvas tkag. So this canvas is what will enable you to put in your graph, embed your graph on the Tkinter window. So generally, the way if you just put in ordinary matplotlib codes like that, when you click on the plot, it will rather plot on your Jupyter notebook or your wherever, your console, your terminal rather. So or bring a pop-up screen from matplotlib. So if you're using your PyCharm, it will bring up a pop-up screen. So, but we need a Tkinter window. So that means we need to create one, and that will now have to be with this. So let me show you how to create new windows in Tkinter before we close this whole thing. I'm going to show you how to do this quickly. Okay. So remember, what we want to do in our app is when you click this, a window opens, right? So first of all, we need to write the function that listens to that, obeys this, that we need to tie to this command. We need to use to command one of these this menu. So where is the plot? So here we need to tie a command to this, each of these. So 1, 2, 3. So that we need to tie a command to this, so that that executes a function when we click on the button. So actually you could pull this off, it's not needed here. Okay, so let's start with what did we put in our graph? We did the pressure versus geo arrow plot. So let's start with I will just call that the PRS plot, because it has to do with, yeah. So PRS plot command. You could call it anything you want, but it has to do with P and RS, pressure and RS. So I'm going to define a function specifically for that. So let's do that. So def PRS plot. So we do this. So just like the other buttons, calculate and run sim. So first we want a new window. So if you are opening a new window in Tkinter, a simple function you use is the top level function. So I'm going to show you now how to use it. So I'm going to show you how to use it now. And yeah, so let's start quickly. And so I'm going to first of all define a kind of a plot window. Let me define a plot window object like a variable plot window. I'm going to call it plot window. You don't have to call it that. So plot window, yeah. So and then I'm going to assign a value to it. Assign the top level object to it. So top level, you enter in the window. You enter in window here because window is your object variable. So window. It's your home page, or more like your domain, your home page object. So you enter it here, and then you could write your functions here. So once you do that, generally a plot, a window should show, because of this top level, a window should show. So let's try this. Oh, I've already given this command. Okay, what did he say? PRS plot command. I didn't name that function properly, so let me name it properly. I'll just take a little break. I think I'm beginning to be exhausted. Okay, so it's great. So let's run this again. Plot menu dot say command equal to PRS plot command invalid syntax. Oh, did we put this in the right place? Okay, I guess we didn't. Oh shit. Okay, guys, I just discovered now that I put this in the wrong place. Okay, it's by mistake anyway. So where is my add command? Yeah, that's the right place. I forgot to put comma, right? Okay, it's correct, it's correct. So that is basically it. So it should work this time around. Okay, it should work this time around. Okay, great. So yeah, so a window comes up top level. So this is the window where your graph will be plotted. So let's quickly, so how does the graph works? The graph simply works like the table. So it plots, first works, brings in several values for maybe for pressure years first, and also for ROS. But the only extra thing will be the matplotlib codes will add to plot the to actually plot the graph. So here we go. Let's plot this graph. Okay. So here's our command. Okay, great. So we have our top level command here to open a window, but we need to do more than this. We need to plot this. So what we'll simply do is to first get our value of P and the rest of them. But we'll still need to get, okay, let's get, okay, a simple thing we could do, it's first to calculate ROS, right? So we need pressure to calculate ROS, different values of pressure to calculate ROS. So to do this, we just need to use the S function. Okay, so what I'll do now, look at, here's what I'll do. P equal to, so I'm going to just copy exactly the same functions from here, exactly the same thing from here. Except the insert, of course, I don't need it. Okay. Great. Oh, what have I done? So I may not, I actually don't need the plot, the for loop. Okay, let me just remove the for loop. I don't need it. So I'll just copy this, because what I want to do now, I want to copy this from here. I want this function to calculate everything afresh and do my plot for me. It's not supposed to be so. If I were doing using classes of object-oriented programming, this would be far easier. So let's quickly do that. So what it does is to plot all these, yeah. So is to plot all these even though I don't need them, but let's just leave them there first. I don't need all, but I will not want to be taking time to pick up the ones I need. So let's just create this x and y function, x and y variables that we use for our plotting. That's all we want to know. So let x will actually be p, right? So we are going to write a for loop, for an inline for loop for p, or rather we could use a range. Okay, better this way. Let's use a range, and then we put in our float e here. Yes, so we have to convert it to an integer, of course, you remember. So let's convert this to an integer. So we have we have 100 and we have -100. That is a sequence. It's more like more like a list. So y will, so this where we have to write a for loop. So we'll say ros for, okay, no, we have to write this function ros. So we just have to write this. Of course, this is the only thing we really need. Uh, yeah. Okay. What happened? My screen. Oh, I thought the network stopped. Okay, good. It's still fine. All right. So where are we? So we are currently at trying to get this right. So it's basically simple from here. It's basically simple from here. We could we've, we could just use this yeah. So for this is where we use the for loop for p in this x we have already defined here. So with this, you will get two values here. So I'll quickly rush over this. So with this, we have gotten our x and y, and we are almost good to go. So here is how you plot. Of course, if you have been using Matplotlib, you'll be used to this particular function, this particular syntax and code, plt dot plt dot figure figure, and then you have fixed size. Let's define the size of the figure in inches. So we have 5 and we have comma 4, and then we have uh, this means dot power. I don't need it. Okay, so I want to put it, but it's not necessary. So so let's add the subplot fig dot subplot subplot. So I'll do only one of the graphs and I'll let you do the rest. So okay, so dot plot, then this where you put in your x and y. You pass in your x and y. Then with this you are good to go. Yeah, so we are fine and we are doing great. So we're actually done with the matplotlib codes. It's just what we need for the matplotlib. So the next thing we need is just to embed it. So it's time for us to embed it using canvas and tkagg. So that is just it. So I'm going to do something like let's call it a chart, chart, equal to figure. Now, if we are using PyCharm, this would have been very easy because PyCharm is an intelligent editor. It will help you to complete these spellings, these ugly spellings. So tkagg, then we have fig, and then we have dot pyplots. Yeah, sorry, plot, not pyplot. I think, what did I name my window? My new, oh, plot window, sorry. Plot window. Okay, so we are almost set. So the next thing and the final thing actually for this particular function is to pass this argument, this method rather. So we have charts. I'm using chart. You could use anything. Chart dot. I will just call it chart one, and then okay. Chart dot get. Okay. Let's call a widget. So to pack it, we use to fix it in place. We can just use the pack method, and that is all. Hope we didn't have any spelling. Let's see our mistakes so that we correct them quickly. So PVT back.gas, what did it say? Invalid syntax. So what is our invalid syntax here? Let's quickly check it. We probably made a mistake here in our plot menu. Okay. So x is equals to range inter gas solubility. Is this what we have here? Okay, ptyg. Okay, so what exactly is our problem for p in x? We have range. Okay, guys, I just put this in. This again, it's not needed. I need it here. Okay. Great. So I guess I've been able to correct my errors. So this spelling wasn't correct. Okay, good. So let's go on. Okay, good. PVT.gas. Everything is looking good. So we can move. So let's run this and see. We are done with our matplotlib code if this works fine. So let's quickly work on this. See, once our chart plots, I think will be done for today. 7.5. Okay. Leave it. Sim plot. Great. A mistake, an error. Has no attribute plot window. Okay. I've probably used where I'm not supposed to use it. Where is it? Okay. So what I need to do now is this. So it says there's no attribute plot window. So I think I made a mistake there. Great. So let's see if this works fine. If it doesn't, we correct the error and it will work fine. Just well. 7.5. Run sim, calculate, plot. Great. So I think we can stop here for the day. What you have to do, I want you to go and work on it. It's exactly the same codes, syntax, just for the other plots. So here we have PROS plot command. So you could give other commands. But let me show you quickly how to convert your files to dot executable file. If you look here, if you see here, my file, it's already an executable file. So if I click open, it opens. And then I used this dot set method or set method to put in some values here. So with this, you could transfer this to any computers. You could actually change this icon to whatever you want. I didn't bother doing that. And I'm hurrying up because it's going to take a lot of time to do that installation. And I'm not gonna pause the video. So okay, so I've already installed it, but it's okay, it's fine. I'm going to just show you how to do it, and we'll stop there. So so this is it. This is what we have. I put this, I set this values as default value, so I could always use it here to just run this app. So this way it's an executable file. So I'm going to open my PyCharm. If we take our codes here, yeah, so our PyCharm is opened. I already have this script here having exactly the same codes. So I'm not gonna you could actually copy the codes directly from here, Control A, and then I Control C it, and then I move straight to PyCharm and paste it in a script, but I already have them here. So I'm just gonna show you how to convert this. So let's hope this works fine. Okay, guys, I'm going to actually stop the video here, and I'll make a short video for the installation, for the installation, for the conversion to .exe file. So that I'll make a short video for that. That will be part C of this video, and it's going to be less than 5 minutes. So thank you very much, guys. I hope you have a nice time. Like I said, feel free to contact me if you are, just in case you are stuck. I actually love resolving the issues and the problems with codes. That's what I love doing. So, and I'm sure you saw me do it a number of times. So that is it. Thank you, guys. Have a great time coding. I love to see your own apps. I love to see your own applications. I would love to see your own inputs. If you have better ways of coding this, you could always reach out to me and we talk. Thank you very much. Take care.